January 27th, 1945, southern Kyushu. The night sky had only just gone quiet. Hours earlier, the deep drone of aircraft engines had rolled over the hills, shaking the earth as American B-29 Superfortresses crossed Japan's southern skies. The fires they left behind still smoldered. Rows of wooden houses burning in the distance, telephone wires hissing in the rain. Near Kagoshima, a small unit of Imperial Japanese Army mechanics picked their way through a blackened rice field. Their boots sank into the mud, flashlights cutting pale tunnels through the mist. Ahead of them lay something massive, broken, and strange. It wasn't the fuselage of a Mitsubishi or Nakajima bomber. It was far larger, with smooth, riveted panels and enormous wings that had sheared off on impact. As they drew closer, the white star and bar of the United States Army Air Forces came into view, smeared with oil and ash. The nose section had torn open, spilling an impossible sight. A labyrinth of colored wires, circuit boards, gyroscopic instruments, and control boxes. It looked less like an aircraft and more like the inside of a power station. One of the younger men knelt, brushing away soot. He touched a row of intact switches, each labeled in neat English letters. "It's alive inside," he murmured. The others said nothing. They knew they were staring into the future, and it did not belong to Japan. By early 1945, Japan was fighting a war it could no longer win. Its empire still stretched across much of East Asia, but its skies had become enemy territory. The Americans had captured the Mariana Islands the previous summer, Saipan, Tinian, and Guam, transforming them into forward bases for a new kind of bomber. The Boeing B-29 Superfortress. From these islands, 1,500 miles from Tokyo, the United States could finally reach the Japanese mainland with ease. The B-29 was unlike anything Japan had faced before. It was faster, flew higher, and carried more bombs than any aircraft in existence. At 30,000 feet, its crews flew in pressurized cabins, while Japanese interceptors gasped for air far below. Radar-directed turrets, remote-controlled by gunners seated amidship, gave the aircraft an invisible shield of 50-caliber fire. To Japan's defenders, the first encounters with these massive bombers felt surreal. The sound came first, a deep, pulsing roar that shook windows before the aircraft even appeared. Then came the flashes, the concussions, the steady rain of incendiaries. Even the best Japanese fighters, the Ki-84 Hayate and the N-1KJ Shidenkai, struggled to reach the B-29's altitude before running low on fuel or overheating their engines. In the towns below, civilians watched silver dots move across the sunlight, too high to shoot down, too distant to fear until the air turned orange. The Japanese High Command called them Bisan Niju Q, Mr. B-29, a mixture of fear and bitter respect. Newspapers tried to downplay their impact, but everyone knew the truth. These new bombers represented an entirely different level of industrial power. For Japan's aircraft engineers, the challenge was personal. They had built machines by hand, with skill and precision, but their designs relied on craftsmanship more than automation. The Americans, by contrast, had turned complexity into an assembly line art. While Japan's Nakajima plants struggled to produce a few hundred airframes a month, Boeing's Wichita and Renton facilities turned out thousands, each wired, tested, and standardized with almost mathematical precision. When the first B-29 wreckage was reported on Japanese soil in late 1944, it was treated as a technical opportunity. Here was a chance to understand what the Americans had created, and perhaps find a weakness. Recovery teams were sent wherever debris fell. Mountain slopes, rice fields, even coastal shallows. Every fragment mattered, but no one was prepared for what they found. The B-29 wasn't just a large bomber. It was a flying system, a network of automation, circuits, hydraulics, and pressurized air. an airplane that almost seemed to think for itself. The mechanics who arrived at Kagoshima that cold January morning had been trained to strip down the simple, rugged Ki-43 or Ki-61 fighters. Now they stood before a machine that used more electrical wiring than an entire Japanese factory. Even in ruin, it radiated sophistication. As they began cataloging the wreckage, they realized something extraordinary. Almost every control, every function, was electric. Landing gear, flaps, gun turrets, even fuel balancing. Japan's bombers still relied on manual levers and cable pulleys. The Americans had replaced muscle with power. That realization would ripple upward, from field mechanics to engineers, in Tokyo, sparking a quiet sense of awe and dread. The Americans were fighting a different kind of war, and this downed B-29 was the first undeniable proof. In the winter of 1944-45, Japan's scientific establishment was already stretched to the breaking point. Factories in Tokyo, Nagoya, and Osaka had been bombed repeatedly. Skilled workers were drafted into the army. Aluminum was scarce, copper nearly gone. Every aircraft engine produced required salvaged metal and improvised wiring. Against this backdrop, the arrival of a crashed B-29 was like discovering an artifact from another civilization. The Imperial Japanese Army Air Technical Research Institute, the Rikugun Koku Gijutsu Kenkyujo, quickly ordered that all recoverable wreckage be sent to Tokyo for study. Even pieces from the countryside were wrapped, tagged, and shipped by rail under guard. One particular wreck from Yamaguchi Prefecture, shot down in December 1944, became a case study. Engineers laid the shattered fuselage across wooden supports inside a hangar at Tachikawa. They expected ordinary aviation technology, mechanical linkages, cables, fuel lines. Instead, they uncovered an electrical maze, wiring harnesses bundled like arteries, multi-pin connectors sealed against moisture, and circuit relays that clicked with mathematical precision. The Japanese term for what they saw was jidoka, automation. But the scale of automation inside the B-29 was beyond anything Japan could replicate. Even the gun turrets were remote-controlled. A single gunner, seated beneath a plexiglass dome, could engage targets on both sides of the aircraft through an analog computer that calculated range, speed, and angle. Each turret moved smoothly on electric servos, precise, coordinated, fast. Japanese engineers dismantled the system carefully. They mapped wires by color and thickness, trying to trace how information flowed between components. The deeper they went, the clearer it became. This aircraft represented not just superior engineering, but an entire philosophy of warfare built on electricity and systems thinking. While Japan's aircraft relied on pilot instinct and mechanical skill, the Americans had designed machines that multiplied human ability through circuits. The pilot didn't need to pull every lever. Automation did the routine work, allowing him to focus on mission and navigation. One investigator wrote in his report, "This is an airplane designed not for pilots, but for engineers." It was a quiet admission of defeat, not in courage, but in technology. At the same time, the Allied bombing campaign was intensifying. Night after night, hundreds of B-29s crossed the Sea of Japan in long, shimmering formations. They dropped incendiaries instead of high explosives, targeting urban centers rather than factories. Tokyo, Kobe, and Nagoya became oceans of fire. Wooden neighborhoods vanished in hours. The Japanese Fighter Command tried to adapt. They experimented with ramming tactics. Tayatari, using obsolete planes loaded with minimal fuel to strike B-29 formations. They trained radar operators to detect high-altitude intruders, but the American bombers flew too high and too fast for consistent interception. In the midst of this chaos, engineers continued their quiet investigation of the downed Superfortress. They studied its pressurization system, a network of air ducts and seals that allowed crews to operate in shirt sleeves at 30,000 feet. They examined the remote fire control computers, small metal boxes filled with gyroscopes and vacuum tubes. They even tried to copy the cockpit oxygen regulators, only to find that Japan lacked the materials to produce similar valves. The reports circulated through the Army's technical divisions. A few officers hoped to imitate some of the simpler designs for their own bombers, but it was too late. Japan's industrial base was collapsing, and even the basic alloys used in American wiring were unavailable. Still, the discovery left a deep mark. The mechanics who had once believed in the invincibility of Japanese craftsmanship now saw that America's true weapon was not just size or firepower, it was standardization, precision, and relentless innovation. And as the B-29s returned to Japan's skies each week, those same men would look upward, knowing that every engine hum above them carried the secret they had already uncovered. The future of warfare was electrical. When the inspection of the Kagoshima wreck began in earnest, the Japanese technicians treated it with the reverence of archaeologists. Every panel was photographed, sketched, and labeled. What had once been a machine of destruction was now a textbook, one that exposed an entire system of industrial thought. The first thing they noticed was the wiring. There was so much of it. Thick bundles ran through the fuselage like veins, branching into every compartment. Color-coded insulation separated electrical lines for power, control, and communication. Each wire ended in a connector, perfectly machined, moisture-sealed, and designed for quick replacement. In Japanese aircraft, electrical systems were simple: a starter motor, a few instruments, gun triggers, maybe a landing light. The B-29 was an electric organism. Every system, turrets, flaps, bomb doors, pressurization, even the central fire control, was controlled through electricity. When engineers examined the remains of the gun control system, they realized it was decades ahead of anything Japan possessed. The analog computer, the General Electric Central Fire Control Unit, could track a moving target using data from gyroscopes and optical rangefinders. The Japanese had relied on manual gunnery, a man's eyesight and reflexes. The B-29 turned that instinct into an equation. One report noted, "Every function in this bomber is coordinated by power. The operator is a part of the system, not its master." The pressurization system caused even more astonishment. The cockpit and forward fuselage were sealed, the aluminum skin reinforced with rubber gaskets and airtight joints. Compressed air lines ran throughout, keeping crew compartments livable at altitudes where unprotected humans would lose consciousness. Japanese bombers like the Ki-67 Hiryu struggled to fly at 20,000 feet without freezing instruments or suffocating crews. The Americans had created a climate-controlled environment inside the sky itself. Perhaps most revealing was the craftsmanship. Each component, from relays to circuit breakers, carried a serial number. Each was standardized, built to fit perfectly, replaceable between aircraft without modification. In Japan, many aircraft parts were still hand-fitted. Factories employed artisans with years of experience, bending panels by feel. It produced beautiful machines, but not scalable ones. One engineer reportedly turned to his colleague and said, almost in disbelief, "This is built like a city. Everything connected, everything powered." He wasn't exaggerating. The deeper they examined the B-29, the more they saw that it wasn't just an airplane. It was the physical expression of an entire industrial system. America had turned mass production into a science, one that allowed complex machines to be built in quantities Japan couldn't dream of. By March 1945, as reports filtered back to the Army's technical divisions in Tokyo, there was quiet recognition. The technological war was already lost. No amount of bravery, sacrifice, or spirit could compensate for what Japan lacked. The materials, the automation, the infrastructure. Yet, despite the despair that lingered in those hangars, there was also awe. The engineers didn't simply hate what they found. They respected it. They admired the precision, the logic, the intelligence of the design. It was humbling because in that wreckage, amid torn aluminum and scorched wire, they saw what the future of flight would become. Machines that thought, systems that anticipated, wars fought not by strength of will, but by mastery of electricity. And for a proud nation of craftsmen, that realization was as painful as it was undeniable. For the Japanese mechanics and engineers who worked through the wreckage of the B-29, the experience was both technical and deeply personal. Many were veterans of Japan's aviation rise in the 1930s, men who had helped assemble the first Zeros, who had believed that precision hands and discipline could overcome any obstacle. They came from a culture that prized craftsmanship as virtue. Machines were built with care, adjusted by touch, and perfected through patience. Now, kneeling in the mud beside a burned American bomber, that belief began to crack. The younger mechanics were fascinated first. They ran their fingers over the neatly labeled circuit panels, opened instrument housings that still smelled of burned insulation, and passed components between them like relics. Some spoke quietly, trading guesses about what each piece did. The voltage regulator, the pressure valve, the oxygen control. Others just stared, silent, trying to make sense of how a single aircraft could hold so many systems. Older supervisors, men who had seen years of shortages and improvisation, reacted differently. They understood what the wreckage truly meant. Japan could not match this level of production, not anymore. Its factories lacked copper for wiring, alloys for components, even fuel for testing engines. The B-29 represented an enemy who fought with endless resources, a machine that embodied the industrial heartbeat of America itself. When the engineers' reports reached senior officers, reactions were mixed. Some dismissed the findings as irrelevant. They insisted that spirit and loyalty would prevail, that Japan's pilots would simply adapt. Others were shaken. One colonel at the Tachikawa research site reportedly said, "They are fighting with electricity, and we are fighting with muscle." He wasn't wrong. Even in daily life, the war had taught Japanese citizens to equate scarcity with virtue, to reuse, repair, and endure. But this machine reflected a world where abundance created innovation. The Americans built with excess energy, materials, manpower, and that excess had allowed them to think beyond survival. One engineer's diary entry from early 1945 captured the emotional core of that realization. "We are proud of our skill, but the Americans have built something that no single man could. It is not just their airplane that defeats us, but their way of working." Among the younger mechanics, there was also curiosity, even admiration. A few confessed they wished they could see a B-29 in flight, just to witness how such a system came alive in the air. It wasn't treason. It was the natural wonder of engineers seeing something extraordinary. Yet their wonder was always shadowed by the sound of distant bombers. Every time the sky began to hum, they looked up, remembering the wreckage they had studied. They knew that for every B-29 that fell, hundreds more were already being assembled across the Pacific. As one senior mechanic remarked quietly during an air raid drill, "We could study 1,000 of them, and it would not matter. They are already building the next 1,000. The discovery of that crashed B-29 didn't just expose the technological gap between nations. It revealed a deeper divide, a contrast in how societies imagined progress itself. And as the bombers returned, night after night, Japan's engineers could only watch the sky and recognize what they had learned too late. This war would be decided not by courage, but by circuits, factories, and electricity. By March 1945, the sound of the B-29 had become part of Japan's nights. It was a mechanical pulse, distant, heavy, and constant. For the people below, it signaled not a single attack, but a campaign that never seemed to end. The bombers came in formations that stretched across the horizon, their navigation lights glowing faintly at impossible heights. From the air bases of Tinian, Saipan, and Guam, the XD-1 Bomber Command launched waves of superfortresses under the command of General Curtis LeMay. Each carried up to 10 tons of incendiaries, mixtures of magnesium, phosphorus, and napalm, engineered not to destroy buildings, but to erase cities. The strategy was simple and devastating. The B-29s no longer targeted factories or shipyards. They targeted neighborhoods. Japan's cities, built of wood and paper, became tinderboxes. On the night of March 9, 1945, 334 B-29s crossed the coast and unleashed a firestorm over Tokyo. Entire districts, Asakusa, Kanda, and Ueno, vanished in hours. More than 100,000 people died that night. In the chaos below, air defense officers tried to track the bombers, but radar screens glowed with too many signals. Interceptors climbed but never reached altitude. Pilots saw only silhouettes against the moon before engine fires forced them back down. Inside the Imperial Army's technical divisions, reports from the engineers studying the B-29 wrecks now carried a new urgency. They no longer read as research documents but as warnings. They confirmed what Japan's commanders were already witnessing firsthand. The Americans had achieved an unprecedented synthesis of technology and production. Every system inside the B-29 existed to serve one purpose: precision and endurance. Pressurized cabins allowed crews to fly higher and longer. Remote turrets protected them from interceptors that barely reached their altitude. Oxygen regulators and redundant electrical systems ensured missions could continue even when the aircraft was damaged. It was an instrument built not just for destruction, but for persistence. In Tokyo, military engineers gathered to discuss countermeasures. Could they replicate any of the systems they had studied? The answer was no. Japan's production lines were scattered, its supply chains broken, its power grids failing under bombardment. Even if they could understand the technology, they could no longer build it. At one meeting, an Army technical officer summarized the situation with brutal honesty. They build their planes the way we build our cities, with power and planning. The realization hit hard. The crash recoveries and technical studies that had begun as opportunities now felt like autopsies, post-mortems, of a nation's industrial limits for each. The engineers who had examined the B-29's inner workings, watching those same aircraft burn through Tokyo's night sky, felt almost surreal. They had seen its heart, the circuits, relays, and systems that made it more than metal. And now they were watching hundreds of those hearts beating over Japan, unstoppable and synchronized. The war had reached a turning point. The gap revealed by that wreckage in Kyushu was no longer theoretical. It was now visible, audible, undeniable. The Americans had built an air fleet that Japan couldn't even imitate, and every B-29 that appeared over Tokyo was a reminder that technology, not valor, was now the deciding weapon of the war. In April 1945, the Japanese technical bureaus submitted their final consolidated reports on the B-29's design. The findings were comprehensive, detailed, and quietly devastating. They confirmed that the Americans had achieved a full electrical integration of aircraft systems, something even Germany had only begun experimenting with. The analysts noted how the B-29 to power distribution system used redundant generators and bus bars, ensuring that if one circuit failed, another automatically took over. Its communication lines were shielded against interference. Its flight control instruments used synchronous motors to eliminate lag between pilot inputs and mechanical response. Every switch, every dial, had been standardized for reliability. The conclusion was understated but clear. No nation currently at war with the United States can reproduce this machine. For Japanese engineers, those words carried the weight of resignation. They weren't spoken publicly, but everyone in the technical divisions understood. The empire's aviation industry, once proud of its innovation, now faced a truth it could not change. At the same time, General LeMay's bombers intensified their raids. Osaka, Nagoya, Kobe, and Yokohama followed Tokyo into fire. Entire cities vanished from maps within nights. In the ruins, factories stopped producing. Transportation collapsed. Japan's air defenses shrank to scattered remnants. The B-29 had become more than an aircraft. It was a symbol of inevitability. It represented a kind of warfare Japan could not touch, the projection of industrial power across oceans. Each superfortress that appeared in the sky was not just a bomber, but the physical manifestation of a nation that had mechanized genius itself. In May, as the Imperial General Headquarters reviewed the losses, they discussed the enemy's next move. Some believed the B-29s would soon carry new weapons, far deadlier than firebombs. They were right, but no one yet knew what was coming from the labs at Los Alamos. Back in the hangars at Tachikawa, the captured wreckage remained under guard. The engineers still worked through it, methodically drawing schematics, making notes, tracing wires. Even as cities burned, they continued their study. Part duty, part disbelief. One senior engineer, who had once overseen engine design for the Ki-84, stood before the gutted fuselage and said quietly to his staff, "This is what an empire of machines looks like." Those words would echo through Japan's post-war reconstruction decades later. When many of those same engineers went on to rebuild the nation's industries, drawing lessons from the wreck they had once studied in secret, but in 1945, as the summer approached, that lesson came too late. The gap between American and Japanese technology was no longer a matter of innovation. It was a gulf defined by power grids, supply chains, and factories operating around the clock. Japan had mastered the art of craftsmanship. America had mastered the science of systems, and now those systems were burning the old world away. By the time U.S. bombers began flying from Iwo Jima, escorted by P-51 Mustangs, there was no doubt left in any Japanese mind. The empire that had begun this war through daring had met an enemy who fought with precision, electricity, and endless production. The mechanics who had first touched the wreckage at Kagoshima could look at the night sky and recognize the same machines. Alive, relentless, and impossibly far ahead. When Japan finally surrendered in August 1945, the reports on the B-29 were still filed neatly in the archives of the Army Aeronautical Technical Research Institute. Some pages were charred from the fires that swept through Tokyo's suburbs, but most survived. They were dry, clinical documents, hundreds of diagrams, electrical maps, and translated notes. Yet between the lines was the quiet realization of defeat, long before the formal surrender. The American occupation forces that arrived later found the studies untouched. They reviewed them with curiosity, noting how precisely the Japanese had reverse-engineered the aircraft despite their limited tools. The surviving engineers were interviewed by technical officers who were surprised to learn that many of them had never even seen a fully intact B-29 in flight. Only fragments, instruments, and burned-out control panels. In one of the final technical summaries, an engineer had written in pencil, "Efficiency without limit. This is their power." The Americans dismantled what remained of the Institute, but they did not destroy everything. Many Japanese engineers were quietly encouraged to continue their work under civilian industries. Within a few years, those same men would help design Japan's first post-war automobiles, radios, and electrical systems, each bearing the imprint of lessons learned from the wrecked superfortress. For Japan's wartime leadership, however, the discovery of the B-29's automation carried a different meaning. It revealed that the empire had entered a conflict it could never have won through courage or tactics alone. The enemy's advantage was not bravery, but integration, the total merging of science, engineering, and production into a single, unstoppable force. In the Air War's final months, Japan tried to answer with desperation. The Nakajima Kika jet, inspired by Germany's Me-262, never flew in combat. Radar production lagged. Ammunition grew scarce. Yet the American bombers kept coming, their engines droning high above the reach of Japan's remaining fighters. At night, civilians could see their navigation lights blinking faintly at 30,000 feet. There was something almost impersonal about it. Machines passing overhead, invisible pilots releasing fire with mechanical precision. For the Japanese people, the sound of a B-29 was no longer a warning. It was inevitability made audible. After the war, American engineers toured Japan's captured airfields. At one hangar near Fusa, they found the remains of the studied B-29 still under a tarp. Its aluminum skin oxidized, its wiring looted for copper during the final months. They photographed it carefully before scrapping it. One officer noted in his report, "They were trying to understand a machine that belonged to another age." He wasn't far off, because, in a way, that wreck represented more than technology. It marked the moment when one nation realized it had reached the end of its mechanical imagination, and another had moved. Beyond it, the engineers, who had examined the bomber, would soon find themselves building machines again, but not for war. The same precision that once documented American circuits now powered the factories of a reborn nation. From destruction came an understanding that mastery of technology was not in weapons, but in systems. The story of that single crashed B-29 was forgotten by most, yet it lived quietly in Japan's post-war memory, as a symbol of both defeat and transformation. In the months following surrender, as occupation reforms reshaped Japan, the story of the crashed B-29 faded into technical archives and quiet memories. Yet its influence endured, in ways no one at that muddy crash site could have predicted. Some of the engineers who had examined the aircraft were later employed by the new Ministry of Transportation and by private companies like Toshiba and Hitachi. They brought with them sketches and mental blueprints of what they had seen: power distribution networks, centralized control systems, and redundancy circuits that had once seemed alien. These men began to design factory automation and early transistor systems, applying the same logic that had once stunned them in the wreckage. Across the Pacific, American officers who had reviewed Japan's post-war industrial reports recognized something unexpected. Within only a decade, the very engineers who had studied a crashed superfortress were now producing electronics and precision, tools that rivaled the West. What had once been a symbol of humiliation had become the blueprint for recovery. But for the men who lived through it, the memory was more complicated. In interviews conducted years later, several recalled the night they first saw the B-29. They spoke of silence more than shock. One of them, a mechanic named Tetsuo Sano, told a visiting historian in 1962, "We thought we were skilled. Then we opened that fuselage and realized how far behind we were. It wasn't just a plane, it was a lesson." The wreck itself never became a museum exhibit. Japan was eager to rebuild, not to remember. But among aviation historians, that single aircraft held meaning beyond its twisted aluminum. It represented a turning point, the moment when technological defeat became the seed of transformation. Meanwhile, for the Americans, the success of the B-29 program proved the value of industrial coordination and scientific investment. The aircraft had cost more to develop than the Manhattan Project, yet it accomplished what no other bomber could: precision raids from altitudes beyond interception. Its design set the foundation for post-war aviation. From the Boeing 377 Stratocruiser to the B-47, and eventually the B-52, what Japan's engineers had glimpsed inside that broken airframe was the architecture of a new kind of warfare. One fought, less by men and more by machines connected in perfect synchronization. By the late 1950s, Japan's aviation industry had begun rebuilding under American supervision. The same men who once studied wreckage now assembled components for U.S. aircraft. It was not irony. It was continuity. The student had become the craftsman, shaped by the very system that once destroyed him. For many historians, the episode at Kyushu remains a small but telling scene in the larger story of World War II. The moment when the limits of one empire's engineering met the limitless capacity of another's industry. The Americans had built machines that did not just fly. They thought, adjusting, calculating, and managing themselves with unseen logic. And that was what shocked the Japanese mechanics most of all. Not the size, not the power, but the intelligence woven into steel and wire. By the time peace returned, they understood something profound. Victory in the modern world would not belong to those who fought hardest, but to those who built smartest. The field where the bomber fell was later reclaimed by farmers. Rice grew there again, quiet and green. But buried beneath the soil lay fragments of wire, glass, and aluminum, small reminders of the day Japan saw the future crash from the sky. The story of the crashed B-29 in Kyushu is not about a single battle or a single machine. It's about what happens when two worlds of technology collide. One forged in isolation, the other fueled by boundless production and integration. For the Japanese mechanics who stood in that field, the aircraft was more than wreckage. It was proof that America's strength in World War II did not lie only in its weapons, but in its systems. The vast web of industry, science, and logistics that turned imagination into machinery. What they saw inside that fuselage was order, precision, and scale far beyond anything they had known. The B-29 was an instrument of destruction, but it was also a testament to human ingenuity. Its circuits, servomechanisms, and autopilot systems foreshadowed the post-war age of automation. In that sense, Japan's defeat became its education. The engineers who once tried to understand the bomber's secrets would go on to shape the very industries that defined Japan's modern identity. When viewed from history's distance, the scene feels almost symbolic, the broken machine that revealed the future to those who sought to destroy it. The B-29's legacy endures not only in the power it once projected, but in the quiet influence it left behind. From its ruins, two nations emerged transformed, one victorious through innovation, the other reborn through understanding. And in that quiet, rain-soaked field of 1945, the world's next century had already begun.